Hello everyone, and thanks for watching Edupedia World videos. In this video, we'll be discussing solutions to problems in the second paper of the 2013 JEE Physics Advanced Question Paper. I'll be working with code 0, but in any other codes the question will be the same, just the order will be shuffled, so you can figure that out for yourself. Let's look at 13 and 14. We are given a charge q rotating in a circle of radius r with an angular speed omega, and we are given that it can be considered equivalent to a loop carrying a current q omega by 2 pi, which is, if you were wondering where it came from, which is just q by t, right, where t is the time period. So this is the current, and the magnetic field increases at a rate of 0 to b in 1 second, right. So basically the magnetic field is b into t, where t is the time between 0 and 1 seconds because it increases linearly. So what is the EMF induced in the loop? It is minus d phi by dt, right, is equal to minus d. Phi is the area into the magnetic field, which is the flux. Area is pi r squared into the magnetic field, which is bt by t, is equal to minus b into pi r square. Right, the sign at this moment doesn't matter, right, and this is equal to the electric field into 2 pi r, because we know the magnetic field is along the axis, so electric field will be in the circumferential direction, which gives us, again the sign really doesn't matter, we are just talking about magnitudes, so E is equal to pi cancels br by 2, which means the answer is B. So the answer 13 is B. We are only asked the magnitude of the electric field, induced electric field. So br by 2, which is B. Let's look at 14 now. The change in magnetic dipole moment is, and in the comprehension we are given that the magnetic dipole moment is gamma times the angular momentum. So delta dipole moment we are already given is gamma times delta angular momentum. So we can use this to solve it, right? So we need to know that angular momentum change, this is equal to gamma into, we are given that the radius of the circle is constant. So r square mr square I into delta omega. We need to find delta omega. Now the induced electric field will actually slow it down. The magnetic field cannot do anything to speed it up or slow it down because it doesn't do work, but the induced electric field can do work, right? So the induced electric field is br by 2. That means the force, which is QE, which is QBr by 2, will be equal to mass into acceleration, which means the acceleration will be QBr by 2m, right? And we already know that it's going to try to slow it down. It should be a minus here, is going to try to slow it down because the induced electric field will be such that it opposes the change in magnetic field, right? That's the way it works. So if Q is moving in this direction, the current will be coming towards the plane. If the magnetic field is towards the plane, then the induced electric field will be opposite to that, which will try to slow it down, right? So in A is minus 2 pi r by m, it is equal to alpha r. Alpha is equal to minus QB by 2m, which means delta omega will be alpha into the time period. And what is the time period? Sorry, not the time period, the total time in which this change occurs. That total time is 1 second because the magnetic field goes from 0 to b in 1 second. So this is equal to delta omega because t is 1 second. So we get gamma into mr squared into qb by 2m with a minus sign. M and m cancels, which is minus gamma q r squared by 2. I'm missing a b here. B minus gamma r square b by 2, which is gamma r square b q by 2, which is option B. So the answer to the 14th one is option B. Thank you.